happy Friday. You've now had two opportunities, two chances to complete your Fantastic Five. Hopefully you watched yesterday's video in its entirety, because if you did that, you got to see not only different ways to solve these questions, but different ways to check them too. So I can kind of look at your numbers and be able to tell whether or not you're watching the videos or not. So if you're watching this one, you should be watching it before you complete Friday's Fantastic Five. And even though normally on a Friday we would expect our scores to be the highest that they've been for the week, a little bit different since you've only done it twice today and only seen me go over it 2 times. So like I said in yesterday's video, we are going to do these same 5 questions next week. Just a little bit more challenging since you're going to see them 8 times before your quiz next Friday. So this video definitely won't be as long today because I don't need to go into as much detail, but gives you another chance to take notes. You can pause play as you wish, but we will go ahead and get right into it with number 1. It says convert 15/4 to a mixed number. So you should look at 15/4 and you should remember what we call that. Since our numerator is bigger than the denominator, that is an improper fraction. So I'm going to go ahead and rewrite it here. And the most important thing when we're going to convert that to a mixed number is what that fraction bar really represents. And you got to think division. Fraction bar means divided by. So yes, we say this is 15/4, but really you want to look at it also as 15 divided by 4. Because when we're getting a mixed number, we got to have a whole number, got to have a fraction. So how many whole times can 4 go into 15? 4 times what is going to get me close? So if you know your facts, you know it can go in 3 whole times, which becomes my whole number. Because when I do 4 times 3, that gets me to 12. I'm trying to get to 15. If I did 4 times 4, I'd go over. So 4 times 3 got me to 12. I'm trying to get to 15. Whatever my remainder is, whatever's in that gap is what's going to be my numerator. So 12, 15, that remainder would be 3, which like I just said is my new numerator. And the denominator doesn't change. If I'm in fourths over here, over to the right, I'm going to be in fourths as well. So if I took 15/4, converted it to a mixed number, that would give me 3 3/4, which is A. Now, I'll come back and check this one in just a second because I'd rather do number 2 and then go back to number 1 and we'll check. We'll check them both really at the same time. So I'm not going to erase that quite yet. But I am going to move down to number 2 where I'm doing the opposite. It says convert 3 2/3 to an improper fraction. So this time I've given you a mixed number and I need you to change it to what we just had, which was an improper fraction. So you just saw this for the first time yesterday. But again, it's just 2 steps. It's like a cycle. So I would rewrite my mixed number. I've got 3 2/3. And if you remember yesterday, we do something at the bottom with your denominator and your whole number, and then we do something at the top, whatever number you get here with your numerator. So starting at the bottom, the first thing we do down here is we multiply, and then whatever product you get at the top, you are going to add that numerator to it. So starting with 3 times 3, that's going to give me 9, plus my numerator of 2 gives me 11. And just like with number 1, that denominator does not change. That gives me 11/3, which is B. The way that we talked about yesterday, where I could check these is let's focus on number 1. If I got my mixed number and I got 3 3/4, I could just change it back to a mixed number. To make sure it matches the one, or change it back to an improper fraction, sorry, to make sure it's what I had. So we just did that. So look right here. If I want to change this mixed number back to an improper fraction, I do something at the bottom, something at the top. I would start by doing 3 times 4, which gives me 12, plus my numerator of 3 gives me 15, and that denominator doesn't change. If these 2 improper fractions match, then I know I had the correct mixed number. And I know it's kind of tricky with me saying all these, using all this academic vocabulary, but the more we use it, the more you'll be able to kind of relate to what I'm saying. Same thing for number 2. I had a mixed number. I just changed it to an improper fraction. I got 11/3. But I could take that improper fraction and change it back to a mixed number because I know fraction bar means divided by. So how many whole times can 3 go into 11? 3 times what is going to get you close? If you know your facts, you know it goes in 3 whole times. So that's my whole number because 3 times 3 gets me to 9. When I'm trying to get to 11, whatever that remainder is becomes my numerator. 9 here, 11, my remainder would be 2. And the denominator doesn't change. If my two mixed numbers match, then I know I had the correct improper fraction, which was 11/3. So I think I said this in the video yesterday, but if you get number 1 right, you should get number 2 right. You shouldn't get one and miss the other, because if you're doing it, if you're following the steps and checking it correctly, then that means you can do both of them. Obviously, if you make a math mistake, that's a little bit different. But I would expect the people who miss number 1 to miss number 2, and vice versa. If you get number 1 right, you should be getting number 2 right. They go together hand in hand, as long as you're checking them. Kind of similar to number 3. If you just check it, there's a really good chance you're going to get it right. And if you focus on keywords that we talked about in class, there should be a way that you can instantly know without checking, really. But if I'm looking at number 3, it says, time to organize Charlie's toys. He has 153 action figures on the floor in his room. If I can fit 7 toys in a bin, how many bins will be completely full? Completely full is important. So you got to kind of try to figure out what you're doing here. But if you know you're putting an equal amount of toys in bins, equal amount makes you think division. And then obviously you look at your answer choices, they're all getting smaller. So that would make sense. Now, if you do the division wrong, then you're going to miss the question, obviously. But we're finally, well, we've been out of school for 2 weeks, so we might be a little rusty. But before we got out for Christmas break, we were finally starting to roll on that long division, which was awesome. All right, so dangerous monkey swiped bananas. Start with division. We know that 7 cannot go into 1. So yes, you could put a 0 and follow the steps, but we're just going to look straight at 15. So how many times can 7 go into 15? If you know your facts, you know it goes in twice. I got fat fingers. There's my division. Then if I multiply by that number that I just put at the top, 7 times 2 gives me 14. And if I subtract 15 minus 14, that gives me 1. Go ahead and bring down the number that I haven't used. Haven't used 3 yet, so that can come on down. And once I get to this point, I get to start all over. So back to the top with division. How many times can 7 go into 13? 7 times what will get me close without going over? With 13, 7 can only go into 13 one time. Because if I did 7 times 1, obviously that just gives me 7. 7 times 2 would put me over the top. So I'd put my 7 down there, and I would subtract 13 minus 7, which is going to require some regrouping, but ultimately you're still doing 13 minus 7. And if you did that math, that's going to give you 6. So when we get to just doing the long division, if I did 153 divided by 7, I would get 21 remainder 6. And you know you cannot have any, there's no such thing as 21 remainder 6 full bins. So we got to interpret the remainder. 3 possible answer choices, right? You could ignore the remainder and say the answer is 21. You could take that remainder to help you push up to the next number. You could have 22 completely full bins. Or you could say, hey, that remainder is going to be my answer. And you could say, I have 6 completely full bins. So I've got 3 possible answer choices, which automatically means D can get eliminated. It wasn't one of the ones that I came across. And then all I got to do is check with what information it gives me. I could have 21 completely full bins with 7 toys in each, 22 with 7 in each, or 6 with 7 in each. So logic helps you out a little bit here, because if you're saying you only had 6 completely full bins, that's only 42 toys, and you've got 153. You could fill way more than 6. So logic would tell me that one I could go ahead and get rid of. So now I got to check the other 2, and I don't know them off the top of my head. That's why we learn how to stack and multiply. I can try 21 completely full bins or 22 completely full bins. So I'll start with 21. In the ones place, if I go 7 times 1, I get 7. 7 times 2 in the tens place gives me 14. And then if I go over to 22 full bins, 7 times 2 gives me 14. 4 stays, 1 goes. 7 times 2 once again gives me 14 plus 1 gives me 15. You should be able to stop right here and automatically choose your answer, because one of these is not possible, guys. You only have 153 toys. There is no way you can fill 22 bins, because if you fill 22 bins, that's going to require 154 toys, which you don't have. That's not something that you can possibly do. So when you only fill 21 bins, yes, that's only 147 toys. But you got to kind of go back to your original answer when you had 21 remainder 6. This number right here is always going to represent what is completely full. That doesn't mean it's going to take me 21 boxes or 21 bins. That's just how many will be full. So 21 full bins, and I'll have 6 left over. Obviously, I would take those 6 and put them in a bin by themselves, but it's not going to be full. So depending on what this question asks, I could use 21, 22, or 6. If it's talking completely full, it's going to be 21. If it wanted to know how many bins I would need to get every single toy, then it would be 22, which would have a little bit of extra room. And if I wanted to know how many toys would be left over or how many toys would be in the last bin, then you would say 6. So you got to think about what the question's asking and see what makes sense. But for this specific question, 22 is impossible. You don't have that many toys, which would mean it would be 21 completely full. Remember, this number right here is always going to represent that. That's the anchor chart that we've got in class, which obviously you don't have in front of you, so that makes it a little bit harder. But when you're interpreting that remainder, just depending on what the actual question is, you could have 3 possible answers. That's why we find them all and check them. I love those questions. I think those really make you think. All right, moving on to number 4. Again, I'm filming these videos before you've even done the first day of this. I'm assuming number 4 would probably be the lowest since we had never seen it before. I guess number 2 could be that way too. But I think this one will take the most practice. And going to next week, the numbers are going to get bigger. So it does get more challenging than this, but knowing your multiplication helps so much. So it says, which answer choice below, which fraction below shows 18/20ths in simplest form? So if you remember yesterday, really there's 3 things you got to do here. Once we rewrite the fraction 18/20ths, first thing we're going to do is we're going to list the factors for the numerator and the denominator. Any numbers that we can multiply to get that numerator and denominator. That's, step number 1. Step number 2 is then we were going to find that GCF. If you remember, GCF stands for greatest common factor. We got to find the number that they each have in common, the biggest number they both have in common. And then the third step is you got to take whatever that GCF is and you got to divide your numerator and your denominator by that GCF. If you do that correctly, it'll give you your fraction in simplest form, and we can check this one as well. Love it. So I'm going to change my color up. We're going to start with our numerator. I like to list my factor pairs in order. So if you want to do it to the side and then put them in order, you can do that. So like when I start with 18, the first one I think of is 1 times 18. Okay, I know 2 is going to be a factor because 18 is an even number, and I know 2 times 9 gives me that. And then I would keep trying any numbers in between 2 and 9 to see if they work. If you know your facts, you know you could also do 3 times 6. And that would be it right there. So 18, you got 1, 2, 3, 6, 9, and 18. Same thing for 20. I would start with my the first factor pair of 1 times 20. I know 2 is going to work because it's an even number. I could do 2 times 10. I could try 3, but I know 3 does not go into 20 evenly. Then I would try 4, which I know I can do 4 times 5. Oops. So for 20, I got 1, 2, 4, 5, 10, and 20. That's step 1. I've listed all my factors. All right, next thing I got to do is I got to find my greatest common factor, the biggest number that they both have. So yes, they both have 1 in common, but that is not the greatest number they have. The greatest common factor these two numbers have would be 2. Once I have found my GCF, I can go ahead and rewrite my fraction down here. I'm going to divide numerator and denominator by that GCF. So if I do 18 divided by 2, that's going to give me 9. 20 divided by 2 is going to give me 10, which gives me 9/10. Now, I'm not automatically going to stop and say, ooh, I see my answer choice, I'm done. Because if you remember from yesterday, I can then take 9/10 and I can try to simplify this. And the way that I know it's in simplest form is if the GCF is 1. So if I listed my factors again for my numerator and denominator, I could do 1 times 9, 3 times 3. And I just put the 3 ones. For 10, I can do 1 times 10, 2 times 5. When I'm trying to find my GCF, when the greatest common factor is 1, I know I'm in simplest form. That answer would be B. So don't always just automatically assume, hey, I listed all my factors, I'm good, because sometimes you may miss a factor, you may pick the wrong GCF, and then you're going to get your answer wrong. So knowing your factors makes this way easier, but taking that extra 30 seconds to check it helps a ton. So that one would be B. And this one I'm hoping, with just a little bit of effort, is one of our best questions. Honestly, we should be Ric Flair in this question, if you ask me. If I want to know which one of those fractions is equivalent to 2/3, which one of those is going to be equal, we know we can toss that x in there. We can cross multiply, butterfly method, whatever you call it. But I can take my 2/3 and I can compare it to every answer choice, which I will do just to show you that it doesn't take you a super long time. And honestly, even if it did, it's worth it if you're going to get the right answer. All right, so we'll start with A, 5/6. We go bottoms up. 3 times 5 is 15. 6 times 2 is 12. Looking at those two numbers, they are clearly not equivalent. So I could eliminate 5/6. Then I would try 3/4. Bottoms up. 3 times 3 gives me 9. 4 times 2 gives me 8. Again, they're close, but I'm looking for equivalent. That does not meet the requirement. Going down to 8/12, bottoms up, I go 3 times 8, I get 24. 12 times 2, I also get 24, which right there shows me I've got a set of equivalent fractions. Best part about this question is I know a lot of you are still going to say, well, let me check that last one just in case, because sometimes I make mistakes. We go bottoms up here. 3 times 12 is 36. 15 times 2. Now, you might not know it off the top of your head. You can go 15 plus 15. You could stack 15 times 2. You know, we've done much bigger numbers than that, but if I did 15 times 2, that would give me 30, which would also prove those two fractions are not equivalent, which would leave me with C. So you very easily could have gone from, and it's just my opinion, you could have very easily gone from like a 1 or a 2 to a 4 or a 5 just from watching one video. So and regardless if your score is going up, you should be happy about that. That's my main goal for you, is to just improve. I don't care if it's from a 0 to a 1, that's a positive. So after watching this, you're now going to go knock out your third day of Fan 5. Now, for Friday's questions, for today's questions, you won't see the review for this one until Monday. So before you start Monday's Fan 5, you'll have another review video that you can watch to help you to get the week started off right. Because by next Friday, I'm expecting a boatload of 5s just because we've had so many days to do it, even with kind of challenging questions, in my opinion. Look, if there's something in the video that you don't think I'm explaining very well, or maybe there's a different way you want to hear it, please reach out and let me know. I'd love to help you. Because you guys know how important Fan 5 is. You see Fan 5 and EOG Fridays. You see it throughout the school year. It's one of the most important things we do. So if there's something you don't understand, make sure you're asking. But if you're ready to roll, go ahead and hop out of here, knock out those 5 questions, rock and roll.